good morning, or good afternoon, or maybe it's in the middle of the night. Whatever it is, hope it's a good one for you. This week, we are just like a little tiny bit ahead. So I'm going to take this week and we're going to make the unit circle, which is something that helps you understand what all this is doing. If it confuses you too much, it's okay. All I want you to do this week is follow along to make your very own unit circle. I will post a printout copy if you have a printer, but I'm going to assume worst case scenario, you don't have a printer at home. I certainly wouldn't have growing up, so we're just going to assume. So I'm going to do it the long way, which I've never done before, but it's going to be kind of fun because I always have these printed out ready to glue into the notebooks. So we're going to make our own unit circle, and then we're going to talk about the 6 trig functions just in part of the unit circle. And the reason I'm doing this is because the lesson that's supposed to be this week really assumes that you understand degrees and radians and know at least some of the 6 trig functions. My audio input capture is really loud. Hold on. There we go. So that's our goal today, is just to make that. That's all we're going to do. Let's make it quieter. There we go. I'm so sorry if I burst your eardrums with this. That's all we're going to do. I'm not going to give you any assignment attached to this. Your assignment's going to be to show me that you have this in your notebook somewhere. Okay, it should be easy. What you need today, what I have today, is I have some sort of lid that is a pretty good circle. Like it's the top half basically of my my notes, because I'm going to write some stuff down here. But we need a lid. A bowl could work. A mouse pad's too big, so I was going to use my mouse pad for this, but it was like just something big. And then I'm going to color code the heck out of this. You know me. So I have a yellow, an orange, and a green. My green's gone, so I'm using this like teal color, but whatever. Some sort of pen or pencil. If you are afraid of messing up, use a pencil. If you're feeling strong and bold and brave, why not use a pen? I'm going to do both, best of both worlds. I'm going to sketch most of my stuff with this gray pen, and then I'll bold it in when I'm feeling more brave. It's fine. So first what we're going to do is we're just going to trace, oh, I should label this. This is 9293. It's a little bit of both, but it's the unit circle. And you're going to reference this a lot. So just make sure you understand it, please. If you don't understand it, it's going to be okay, but it really does help if you understand it. All right, skip a couple lines and then we're just going to trace around. Pause it. Go get your stuff. Go get the lid. Come back. Draw your circle. Press play. Welcome back. We have our circle here. Best you can guess, find the middle of your circle. That kind of looks like the middle. We're just going to assume. Okay, so I have this kind of animation for us. Where is it? Ah, there it is. I named it wrong. I have this animation for us. So here, this is basically going to be our final product, but all filled in with all this information. Don't stress about it yet. All the little boxes are going to be degrees, and all the circles we're going to put in the radians. Because there's some common degrees and radians that I just kind of need you to recognize, and then we're going to figure out what those are. So, hold on to your fraction hats, okay? First of all, this side over here, see how there's 2 boxes on that side? This is 0 degrees, 0 radians. And it's 360 degrees and 2 pi radians. I'm not going to write both of these like all the way out around the whole circle. I'm not going to do that. And if you print this out, you can just fill in the gaps as we go. But I wanted you to know that. And then let's come over here. This is 180 degrees, and that's pi. Okay, so we should already have understood that from last lesson. Okay, so all the way across the circle is 180 which is pi. Okay, now bear with me. Oop, I have to come over here. Oh, perfect. Okay, this is a, this yellow fraction is a part of the circle. It's up here. We have to use a little bit of fraction knowledge, but it's okay. I'll walk you through it. Ready? Okay, so this is 180. This is pi. If I go half of that distance, how much of a pi would that be? I'm hoping you said half of a pi. You're right. Now, we don't usually say half of a pi. What we usually say is we say pi over 2, or 90 degrees. I'm going to come back through later and highlight these ones yellow, because it's going to use our yellow circles. Okay. So that's 90 degrees. I wish I had a ruler right next to me. That would be ideal right now. Let me use this. Oh, here we go. Let me use this little pad of paper. Because what I kind of want to do is I want to draw through the plus. Kind of light. There we go. Now I can actually see what I'm working with. So all the way up is 90 degrees, which is pi over 2. All right. Let's do another one. Oh wait, we already have this one. This is 180, which is just pi. All right, so we have 2 pi over 2 slices right now. Now I have another pi over 2 slice. Okay, so this is 1 pi over 2, 2 pi over 2, 3 pi over 2. So this is 3 pi over 2. And then this is, remember how this one was 90 degrees? So this is 90, 90, 90. So if I go 90 times 90 plus 90 plus 90, that's 270 degrees. Just 3 pi over 2. And then if I do one more, I'm back where I started again, because 90 and 90 and 90 and 90 is 360, which is a total of 2 pi's. Perfect. I'm hoping you're still with me. I'm gonna probably wait until that's dried to color code in. I'm a little afraid right now. What I'm gonna do is I'm gonna be smart right now, and I'm gonna pre-color code in the midway points, because next we're gonna do, was that what we're gonna do next? Yeah. Next we're gonna do the middle of each of these. So I just want to pre-color that in. That's orange, by the way. I know you can't tell because it looks like yellow. All right, so, okay. Now this is halfway. Here's where our fractions go. Here's halfway between 0 and 90. Well, what's the halfway between 0 and 90? That's 45. I should have made that longer. It's fine. Okay, now, this is a fourth of the way around to the 180. It takes 4 of them, because there's this one, that one, and that one. There's 4 of them. So if 4 of them make up a pi, then one of them is a pi over 4. Okay, so this is pi over 4. I'm going to extend that one when I get a chance. Maybe I'll extend these while I'm at it. Okay. There we go. All right, next. If I have 2 of these, I've already filled this one in. This is 90 degrees, which is pi over 2. Now, once again, I'm just giving you some common angle measures, because I want you to have this paper filled out for later reference. My high school, what was it? Pre-calc teacher made us memorize these and do a test. I think yours next year might too, but you know what? It's all good, because you'll understand it a year ahead. That's so not yellow, different than the orange. I love my mild liners, but I need those to look different. It's fine. Okay. So we've already done this one. Let's do the next. Okay. Now I have 3 of them. Okay. If I have 3 45-degree angles, that's 45, 45, and 45, which is 135. And that's 3 pi over 4s. 3 pi over 4s. Okay, still with me? If not, again, it's okay, I promise. All right, one more gets me to 180. One more is 5. Now I have 5 pi's over 4. And that's 45 more than 180 was. So that's 125. No, that's 225. I'm doing this by memory, by the way. That's how much I understand it now. I didn't used to. Okay. One more gets us where we started again, or we're at the bottom again. That's 270, we're good. And then this one is going to be 7 pi's over 4. See how I have 7? 1, 2, 3, 4, 5, 6, 7. Which is 45 more than 270. I think it's 315. If I add 45 to that, that's 360, so I'm good. Whew. Okay, that gets us all the way around the circle. Okay, I'm gonna go back in and I'm gonna attach these again. Where did that pack of paper just go? These ones I might do with like a long dotted line, because I want you to see that they're different. But they're all in the same category. They're all pi's over 4. Where's the middle way? Out of way. That's fine, I don't care. I care a little bit. Okay, we're cutting up our pizza. Next I'm going to use a green circle over here, but I kind of have this like teal color, so we're going to do the midway, kind of the midway. We're going to do thirds of the way around. I'm eyeballing it. I'm just doing the second line above and the second line below, but it really will depend on where your circle is. We're going to do these ones now. All of these? Maybe. Okay. Here we go. This is 1/6 of the way to pi. Okay. See that? How that makes, there's 6 of them. 1, 2, 3, 4, 5, 6. Perfect. So this is a pi over 6. Now, I do this math by saying, okay, if it's 180 and there's breaking into 6 parts, that's 30 degrees. But you can also do it using the 90. 3 of these makes a 90. Okay. 2 of these is 2 pi over 6. We don't like to write 2 pi over 6. What we're going to do is we're going to actually call this pi over 3. Because that's the same thing as 2 pi's over 6. And then 30 and 30 makes 60 degrees. Okay. I personally really wish that pi over 3 was 30 and pi over 6 was 60. That would make a lot of sense. But they're swapped around, so don't mix them up, okay? They're switched. I guess that means do mix them up. Okay, 3 of these makes 90. We're good. Another one. So that was 1 pi over 6, 2 pi over 6, 3 pi over 6. This is 4 pi over 6. Which is the same thing as 2 pi over 3. My brain went, no. Pi's over 6 are down here. Pi's over 3s are up here. Which is 30, 60, 90, 120. Okay, one more. Is 5 pi's over 6. 30, 60, 90, 120, 150. When I was in elementary school, story time, might as well have it like a normal class, right? I sucked at multiplying by 3s. Everybody else is on times 7s. I was so stuck on 3s. My mom one day was like, just memorize them. I hated it. I hate memorizing things. Okay, how many circles do I have now? I think I have 7. So this is 7 pi over 6. Which is, let's see, 150, 180, 210. 7 pi over 6. This is 8 pi over 6, which we simplify to 4 pi over 3, which is 210, 240. Notice that I'm skipping the orange ones when I'm counting by threes. By 30s, I guess. I already have that one. Okay, so if that's 4 pi over 3, this would be 5 pi over 3, or 10 pi's over 6, same thing. 240, 270, 300. So this should be 330, which is one more. 11 pi's over 6. So I'm just going around the circle and I'm counting. That's all I'm doing. Why am I going that way? Which seems like it's cheating a little bit, but that's exactly what's happening here. Not cheating, just counting. Okay, let me take my missing notepad. I keep throwing it over there. And I'm just going to connect these ones through the middle circle with like a shorter dotted line. And the only reason I'm doing that is because I just want you to see that these things are connected in different ways. So I'm going to connect the pi's over 6. With a dotted line. And I'm going to connect the pi's over, oh, did I miss one? No, it's just right here. I'm going to connect the pi's over through with like a, maybe like super dot. It's a super dot, it's super dotty. Now, I, first of all, probably shouldn't sing while I'm doing this because it's on YouTube now. Second of all, if I was super cool YouTuber, I would like fast forward this part of the video. Like it'd be like, alright, so this is super sketchy looking compared to my other one. Like look at my original. Let me go back. I went too far. Okay, look at my original, how the dots are. It's a little bit different, but it's fine. It's okay. I'm hoping you use something light. If you didn't, it's okay. But I'm hoping you use something light because we're going to fill in some more information on this later. But our goals today are to make the unit circle, do some, not backlogging, do some information about just this first section of it. Because, spoiler alert, next week, this section, if it's a pi over 6, it'll be the same numbers for sine, cosine, and tangent all the way around the circle. Same thing with pi's over 4 or pi's over 3, which is pretty cool, I think. But we're going to get there next week. So what we're going to do today, though, is we have this done. We're going to label some of the parts of it. And then we're going to do a sine, cosine, and tangent for just these 5. That's all we're going to do today. All right, so let me switch just back to my pictures because I think we're good with this. There we go. All right, let's label some parts. Oh no, I want to show you something else cool. Okay, this is something oh no, it's gone. Maybe it's there right now. There we go. Okay, so what we're going to do is we're going to take our normal graph and our unit circle, and in our minds we're going to push it together. Okay, so normal graph, unit circle, we're going to overlay them. That way the unit circle is on top of a graph. Okay, don't go too crazy with this. Okay, so in our minds, underneath this we have a graph. And we're going to explain more about what that means next week. But for right now, in our unit circle, in our graph, or graph, we label these by quadrants. Okay. If I had just like a slightly darker gray, I would make that into a graph. It's fine. So we have quadrants in our graph. It's called a Cartesian plane, but you don't learn that till college, basically. So this is, right here, we do a C shape. So this is quadrant 1. And we usually use Roman numerals, which doesn't confuse anybody. It's fine. So quadrant 1, we go in a C shape. This is quadrant 2. Okay. This is quadrant 3. Now, in Roman numerals, the I's mean a 1. And then as we count up, we go, okay, 1 line, this is 2 lines, 3 lines. We don't do 4 lines. We don't. What we do is we say it's quadrant 4. It's 1 before 5 is. Or it's 5 minus 1. If it was 5 plus 1, it would be on the other side. So those are our 4 quadrants. So that's going to come in handy next class. I'm just laying some groundwork right now. It's going to we're doing arts and crafts today. So those are our 4 quadrants. And then the other thing that I wanted to oh yeah. Okay. Now there were these triangles that you learned about, I promise you, in geometry, and then had no idea what they were talking about. Is that too bold? Okay. There were special right triangles. Okay. So let's talk about 2 special right triangles. And I want room over here. So I'm going to pre-write what we're going to do over here so I know I have enough room. So what we're going to do is we're going to do we're going to do 0, 0, 30, pi over 6, 45, pi over 4, 60, pi over 3, and 90, pi over 2. Alright, we're going to do sine, cosine, and tangent. Okay, so I just want this to have like a section. Ugh, did you see that? Look at that wiggle. Gross. Okay. Alright, so special right triangles. So this is a geometry review that you totally forgot. And I just know this. I know this is a fact. Okay, so let's say I have a square. This is me just sketching. Don't, you know. One special right triangle is if I only have half of the square. Okay. In this case, these are both the same angle. These are both 45 degrees because it's half of the 90 degrees that makes up that corner. Let's just say that these are both 1. It doesn't matter. They could be both 30. They could both be a weird number, but we're just going to pretend like they're both 1. You know, a while ago I had sticky notes here. There they are. I see them. Okay, good. We know Pythagorean Theorem by now, so let's do it. If I do 1 squared plus 1 squared, I'll get the hypotenuse squared. Well, 1 and 1 is just 1 squared and 1 squared are both 1. So this is 2 equals the hypotenuse squared. So if I square root that, yuck, the hypotenuse is the square root of 2. That was Pythagorean Theorem I just did. Okay. All right. The other special right triangle is if I have an equilateral triangle. But I only want half of it. Okay. So if that's the case, that's 90 degrees. This is 60 degrees. And this is 30 degrees. Because triangles add up to 180. So each angle is 60, and this top one's 30. Why am I telling you all this? I promise I'll tell you why in a second. All right, let's just say that this side is 1 long. Let's just say. Well, if this side's 1 long and all these sides are the same length, this would be 2 long. And I do Pythagorean Theorem again. 1 squared plus my height squared equals 2 squared. Well, that's 1 plus h squared equals 4. minus 1, h squared equals 3. So that height is the square root of 3. Promise there's a point. I pinky promise. All right, so those are my two special right triangles. All right, now let's just say that I'm over here on my unit circle. I don't want to draw on this. It's fine, it's fine, it's fine, it's fine, it's fine. I didn't tell you I was going to use orange. I didn't know I was going to use orange. Let's just say I'm over here in my unit circle. And I want to find sine at 45 degrees. Well, if I draw that triangle, oof, that should be straight down. If I draw this triangle out, it's this one, because it's 45 degrees, right? Okay, so sine at 45 degrees, if I'm standing at the center, would be 1 over root 2. Okay, we don't like square roots on the bottom. So what we have is we have 1 over root 2. If you ask a yellow calculator nicely, it'll tell you that that's root 2 over 2. All they're doing is multiplying top and bottom by root 2, and then root 2 times root 2 is positive 2. Don't worry about it. This sign is root 2 over 2. You should probably make this box now. Wait, let me finish explaining what it is. These are my angles. So this is degree, and that's rad. I don't know why I have extra space on the bottom. It's fine. Okay. Let's do cosine at the same place. Well, cosine at the same place will also be 1 over root 2. That's the same thing again. Root 2 over 2. I'm going to start doing them sideways so I can fit everything. Is that going to bother me? Yes. Is it okay? Sure. All right. I can also do the exact same thing at the 30 degree or the 60 degree. I haven't used this pen yet. This is this tall, skinny triangle down here. 30 degrees. So if I'm at 30 degrees, you can't see everything. If I'm at 30 degrees, sine at 30 degrees, when I'm standing here, is 1 over 2. Easy. Cosine at 30 degrees is root 3 over 2. Okay, that's fine. Whatever. Okay, let's switch it. Let's go to 60. So I'm standing here now at 60. Sine is root 3 over 2. And cosine is 1 over 2. Okay, we're doing good so far. Now I just want to point this out because people miss this and it's really cool. It goes 1, 2, 3. See that? It counts up. Sine does 1, 2, 3. Cosine does the opposite. 3, 2, 1. Cool. Okay, let's talk about tangent. So remember SOHCAHTOA, which I've been using this whole time and didn't reference. So sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. So tangent at 45 is 1 over 1, which is 1. Cool. Tangent at 30 is 1 over root 3. We don't really like to write 1 over root 3, so we write root 3 over 3. Same thing, same reason as the root 2 over 2. Okay, tangent at 60 is just 1/2. No, it's root 3 over 1, which is root 3. Cosine was 1/2. I did that wrong. It's fine. Okay, now we have to talk about 0 and 90. Okay. Remember when I said that this is like a graph? Well, these points on the graph are 1, 0 and 0, 1, right? It's like a straight line and a flat line. So what we do is sine at 0 degrees. If this is the point 1, 0, sine is the y value. And that works for all of these, by the way. That's pretty cool. So 0, 1, 1, 0. Okay. Did you notice that tangent, if I do like sine divided by cosine, I get tangent. Root 3 over 2 divided by 1 is root 3. 1/2 divided by root 3 over 2 is root 3 over 3. I can do the same thing here. If I do 0 divided by 1, that's 0. If I do 1 divided by 0, that's undefined. So I'm going to turn this. I'm so sorry. That's clearly why I left an extra space. If you were smart and didn't leave the extra space, it's okay. Just write undefined. Okay. All right. Once again, if this is confusing, I really don't want you to stress about it. This took me so many years to actually understand. I didn't have any notes in front of me to do this. I just had my like PowerPoint that has the circle going around it, or the segments. But I just know this stuff now. But I'm 30. I've been doing math for a while. So all I really want you to have at this point is a reference guide of a circle with the degrees and radians that match. Your sine and cosine and tangent for the first quadrant. By the way, this is quadrant 1. Right, this is quadrant 1. And maybe I'll just color code these triangles to show you why they're up there on the graph. Okay. So I'm going to put up a file just to show me that you have this, because I need to check in with you somehow. And I kind of want to see all your cool art. You know, doodle on this, do whatever you want. But I also don't want to give you homework for this because it's just referencing, and I don't need you to prove to me that you can reference a piece of paper. So your only homework this week is to upload a picture of this so I can make sure you did it. Okay. Hopefully that gives you a little bit of a breather, and hopefully that lets you go back and fix any homework. Some of you are emailing me like, it was a really rough couple of weeks to start, but I want to get back on the train. This is a great week for you to get caught up all the way. Okay, go make sure you have everything done, because all the stuff we're doing is going to be, like from here on out, it's going to refresh itself. All right, we're going to add to this next week just like one little tiny thing, but overall what you should recognize are degrees and radians that match, and then kind of how I got this information. I used SOHCAHTOA with 2 triangles. Okay, I hope that you have a fabulous day, or week, or month, all the things. Have fabulous. Be fabulous. You are already. It's fine. And I'll see you next week. Oh, I have big news. Where's my face? There it is. I have big news. I've been doing Corvid courses, which is like doing taxes, insurance, health insurance, calling the doctor, all the stuff that you asked me about in class. I've been doing that, and I'm kind of running out of ideas. So what I'm doing now is in that time slot, which is Wednesdays at 11, I'm going to be live streaming my notes from here on out. So this is posted on Monday. If you want to join me at 11 in 2 days on this channel, I'm going to be live streaming my next notes. So join me, ask me your questions, please. If not, it'll just be like me recording, so it'll be the exact same. It just would be nice to have the little question box on the side, so that way if you're stuck, you can ask me. I might go too fast, because sometimes I do that thing where I say pause and go away and come back, and I can't do that live, but we'll figure it out as we go. So please join me. Be nice to see ya, even if it's just me seeing myself. Okay, that's it. Have a great day. Bye.